Question 3. Given the quadratic functions f of x is equal to 2x squared minus 4x plus 5, express f of x in the form p bracket x plus q squared plus r, where p, q, and r are constants. Sketch the graph of f of x. Our function is f of x is equal to 2x squared minus 4x plus 5. To obtain the vertex form, we need to perform completing the square. First, we need to factorize the 2 outside the bracket. Take the 2 out. We left with x squared minus 2x plus 5 over 2. Now we can start doing completing the square. Put the 2 outside. X is inside the bracket. The square is outside. Minus b over 2. And we need to minus negative 2 over 2 square. And don't forget about the 5 over 2. We simplify the function. 2 bracket x minus 1 square minus negative 1 square plus 5 over 2. Further simplify it. 2 x minus 1 square minus 1 plus 5 over 2, which is 2 x minus 1 square plus 3 over 2. Don't forget to expand the bracket. 2 x minus 1 square plus 3. To sketch the graph of f of x, we need to prepare some information first. Our a value is 2, which is greater than 0, indicates it is a smiling curve with a minimum point. The minimum value is 3. The symmetrical line x minus 1 is equal to 0, x is equal to 1. Therefore, the minimum point will be 1, 3. When x is equal to 0, our y is equal to 5. This is our y-intercept. For x-intercept, f of x is equal to 0. 0 is equal to 2 bracket x minus 1 square plus 3. Bring the 3 to the other side. 2 bracket x minus 1 square is equal to negative 3. X minus 1 square is equal to negative 3 over 2. And this is invalid. Hence, we know that this graph has a smiling curve. Minimum point is 1, 3. 5 is the y-intercept. And there's no x-intercept. We draw the x-axis and the y-axis. Then we plot the minimum point. 1, 3. It is a smiling curve. And the y-intercept is 5. Question 4. A tunnel at a certain part of a highway is in the shape of parabola. The height in meters of the curve of the parabola is given by the function h of x is equal to 15 minus 0.06 x squared, where x is the width of the tunnel in meters. Let's sketch the curve to help us visualize the questions. So this is the tunnel. Parabola in shape. This is the ground, our x-axis, and our y-axis will be the axis of symmetry. In this case, it will be function h of x. Function h of x is equal to 15 minus 0.06 x squared. A. Determine the maximum height in meters of the tunnel. Maximum height of the tunnel occurs at the axis of symmetry, which is this part. Therefore, the maximum height is actually the y-intercept. Substitute x equal to 0 into the function h. We will get 15. Therefore, maximum height is equal to 15 meters. B. Find the width in meters of the tunnel. The width of the tunnel is from this point up until this point. To find the width, we need to find the x-intercepts. Hx is equal to 0. 0 is equal to 15 minus 0.06 x squared. 0.06 x squared is equal to 15. X squared is equal to 15 divided by 0.06, which is 250. Square root both sides of the equation. X is equal to plus minus square root of 250, which is plus minus square root 25 times square root 10. Hence, we get plus minus 5 square root 10. This point will be negative 5 square root 10, and this point will be 5 square root 10. Therefore, the width is 2 times the 5 square root 10. That is 10 square root 10 meters. Question 5. The diagram below shows a suspension bridge. The function of the cables between the two pillars of the bridge is represented by y equals to 1 over 400 x squared minus x plus 150, where x and y are measured in meters. The minimum point of the cable is on the root surface at the middle of the two pillars. This is the x-axis, and this is the y-axis. The curve is over here, and the pillars are here. A. What is the distance between the minimum point and each pillar? The minimum point is over here at the axis of symmetry of the curve. The distance between the minimum point and the pillar is over here. It will be the same for both sides. Hence, to find the distance, we need to find the axis of symmetry. But before that, we need to express the curve in vertex form. Y is equal to 1 over 400 x squared minus x plus 150. Factorize 1 over 400 outside. We left with x squared minus 400x plus 400 multiplied with 150, which is 1 over 400 x squared minus 400x plus 60,000. We put the x here, the square here, minus b over 2. Then we need to minus negative 400 over 2 square plus 60,000. We simplify the equation. 1 over 400 bracket x minus 200 square minus negative 200 square plus 60,000. Continue. 1 over 400 x minus 200 square minus negative negative, we get a positive. 200 square, we get 40,000 plus 60,000, which is x minus 200 square plus 20,000. Then we expand. We get 1 over 400 bracket x minus 200 square plus 50. The symmetrical line is x minus 200 is equal to 0, x is equal to 200. That means this point is 200. Therefore, the distance between the minimum point and each pillar is 200 meters. B. What is the height of the roof above the water level? X-axis is our sea level, and hence we are finding the distance from the sea level, which is the x-axis, until the minimum point. From the equation that we obtained just now, 50 is our minimum value. Therefore, the height of the roof from the sea level is 50 meters. So that's it for today's tutorial. Hope it helps you understand quadratic functions better. For the next lesson, we will try some past year examination questions. So see you again in the next video.